Hey guys, today we're going to start Unit 3, which is Chapter 3 in your textbook, and it is Graphing Linear Equations. Please take notes along with this PowerPoint as I work through all of the problems and give you some websites to go to view more examples. We're going to start the lesson by looking at what is a linear equation. A linear equation is an equation that forms a line when it is graphed. So what we're going to do is we're going to end up taking these equations of lines and we're going to put them on a coordinate plane. We have three basic methods for graphing linear equations. The first one is to make a table. You've probably done that in the middle school. Number two is writing the equation in standard form, is what we're looking at today. And then slope-intercept form is what we hope to get to in our next chapter. Let's look at equations in standard form. When an equation is written in standard form, we can easily graph the x and y intercepts. The equation form looks like this. ax plus by equals c. Please make sure you have this copied in your notes. I will pause and continue with the PowerPoint. We will look on the next slide for the rules of equations in standard form, but just very quickly notice that a and b in front of the x and y, those coefficients will be numbers. C is called the constant and it will be on the right side of the equation. So a, b, and c would be numbers. X and y will be in your equation form. There are some general rules for writing an equation in standard form. And remember, when an equation is written in standard form, we know that equation is either linear or nonlinear. First thing we're going to do is we're going to have x and y on the left side of the equation, and we're going to put the constant on the right side of the equation. We'll manipulate the equation to do this. Next, a is greater than or equal to 0. We don't like our first term to be negative. Our leading coefficient should be a positive number. Then we need to check to see if there are fractions or decimals. We do not want fractions or decimals when our equation is written in standard form. Remember, an equation is like a scalar balance. So if we can multiply both sides of the equation to get rid of the fractions or decimals, we're not changing any values. We then need to make sure that x and y are separate terms. Terms are separated with addition or subtraction signs, so we're not going to multiply x and y together in the same term. There cannot be any exponents other than 1. X squared, not a linear equation. Y squared, not a linear equation. And finally, our GCF of all of our coefficients, our a, our b, and our c, should be 1. If it's not, we will divide every term . Let's determine if this equation is a linear equation. First thing, x and y are on the left side. Well, I'm going to take the minus 3x on the right side and move it to the left side by adding 3x. Next, a has to be greater than or equal to 0. Well, the a in this equation is 3, and it is positive. There aren't any fractions or decimals. The x and the y's are separate terms. There are no exponents other than a 1 power, and the GCF of all the coefficients is 1. So 3x plus y equals 4 is a linear equation, and it is written in standard form. For example 2, the x and the y terms are both on the left side, and the constant 5 is on the right side. Our a is greater than or equal to 0. Our a is 6. There aren't any fractions or decimals, but the second term is x times y. You cannot multiply x and y and be a linear equation. No more work's needed to be done on this problem. This is not a linear equation, and therefore it cannot be written in standard form. Example 3, 2x plus y equals 4, is a linear equation. X and y are on the left side of the equal sign with a constant on the right. The leading coefficient is positive. The exponents are 1. The GCF is 1. X and y are separate terms, so 2x plus y equals 4 is a linear equation. Copy the next example in your notes. 2x plus 9 equals 6y. I will pause for 10 seconds, and the PowerPoint will show the steps to determine whether this equation is linear, and if it is, it will be written in standard form. Example 5, 4x minus 2y equals 16 looks great. The x and y are on the left side with a constant on the right side. There are no fractions, no decimals. The leading coefficient a is a positive 4. And the x and y terms are separated. However, when you look at 4, 2, and 16, the GCF of a, b, and c is not 1, it is 2. So what I'll do to write this equation in standard form to show that it is a linear equation, I will divide every term by 2. Example 6 is a little different. 2.4x plus 8y equals 3.77. X and y are on the left side. X and y are separate terms, and the exponent is 1. Our leading coefficient is positive, but we have decimals. So what do we do to get rid of the decimals? If I multiply every term in the equation by 10, I will end up with 24x plus 80y equals 37.7. I still have a decimal. But if I multiply every term by 100, I have gotten rid of my decimals. 240x plus 800y equals 377. Example 7. 4/3 x plus 2y equals 1/3. Another doozy of a problem. Everything looks good with this equation. It appears to be linear. It looks like it's written in standard form. However, we do have fractions. You cannot have fractions in an equation written in standard form. So what do? We're going to look at the denominator, 3 for 4/3, and of course 3 for 1/3. If I multiply every term by 3, I will cancel out my denominators and not have any more fractions left. Had that been a 4/3 x and then maybe a 1/6 on the right side, I would multiply everything by 6. It's the least common multiple of the denominators. And the last example we will work together is example 8. 2/3 x plus 6y equals 3/5. More fractions. We have to multiply to get rid of the fractions. If I multiply by 3, I'll cancel the fraction on the left side, but not the fraction on the right side. If I multiply by 5, I'll cancel the fraction on the right side, but not the fraction on the left side. So what will 3 and 5 both divide into? And that is 15. I will multiply both sides of the both sides of the equation by 15. take a minute to sketch this on your paper. The horizontal axis is the x-axis, in red on the board. The vertical axis is the y-axis, in blue. Quadrant 1 is in the upper right-hand corner. Quadrant 2, the upper left-hand corner. Quadrant 3, the lower left-hand corner. And Quadrant 4, the lower right-hand corner. The origin, 0, 0, is located where the x-axis and y-axis intersect. In Quadrant 1, both the x and the y coordinates are positive. In Quadrant 2, the x-coordinate is negative and the y-coordinate is positive. In Quadrant 3, both the x and y coordinates are negative. And in Quadrant 4, the x-coordinate is positive and the y-coordinate is negative. As a quick review, we will plot the point 3, 4 together. The first number in the ordered pair represents the x. If it's positive from the origin, you're going to move to the right. If it's negative from the origin, you'd move to the left. Positive 3 will move 3 units to the right. The second number in the ordered pair, the 4, is the y-coordinate. If it's positive, you're going to move up from the origin. If it's negative, you're going to move down from the origin. So if we started at the origin and we moved 3 units to the right, we're also going to move 4 units up, plot our point. We will label this point A, 3, 4.